Bitcoin. You've probably heard of it. Maybe your tech-savvy friend is always talking about it, or perhaps you've seen headlines about people becoming millionaires, or companies buying billions worth of it. But how does it actually work? What makes it so revolutionary and complicated? Well, let's peel back the mystery and break it down step by step. To begin, at its core, Bitcoin is digital money. Unlike the bills in your wallet or the numbers in your bank account, Bitcoin isn't issued by any government or managed by a bank. It's decentralized. There's no organization running the show. Bitcoin operates on a network of computers spread across the world that all work together to verify and update records. How? That's where the magic of blockchain technology comes in. Imagine you're playing a game with your friends, and instead of a referee or umpire keeping score, every single player agrees to write down the score after each play. Everyone has their own notebook, and they all double-check each other's scores at every step. If one person claims they scored 10 points when everyone saw them score only 2, the group corrects that person's mistake. That's a simplified version of what happens in Bitcoin's system. Now, those notebooks are what we call the blockchain, a giant digital ledger that's stored on thousands of computers all over the globe. Think of it as a massive spreadsheet that keeps track of every Bitcoin transaction ever made. But here's the kicker. Once a transaction is added to the blockchain, it cannot be changed or erased. It's permanent. But here's another big question. If Bitcoin is just numbers in a ledger, how do you send and receive it? And how do you know those transactions are safe? This is where cryptography and your wallet come into play. When you own Bitcoin, what you really own is a pair of cryptographic keys, a public key and a private key. Think of the public key as your email address. You can share it with anyone who wants to send you Bitcoin, just like you'd give someone your email address to receive messages. Your private key, on the other hand, is like the password to that email account, except even more secure. It's what you use to sign transactions and prove that you're the rightful owner of the Bitcoin being sent. Lose your private key? Sorry, there's no forgot password button. That Bitcoin is gone forever. Let's walk through a simple scenario. Say you're buying a cup of coffee with Bitcoin. When you send Bitcoin to the coffee shop, your transaction gets sent out to the Bitcoin network. A swarm of computers around the world rushes to validate it. These computers use their copies of the blockchain ledger to check a few things. Is the Bitcoin you're spending real? Do you actually own it? And have you tried to spend it elsewhere at the same time? This is where the magic of consensus happens. All these computers, also called nodes, must agree that your transaction is legit. If everything checks out, your transaction gets grouped with others into a block, which is then added to the existing blockchain. Voila! The coffee shop gets its payment and you get your caffeine. But wait, how do these computers reach consensus? How do they agree on which transactions are valid and which aren't? The answer is something called proof of work, which brings us to Bitcoin mining. Mining is the process of verifying transactions and adding them to the blockchain, but it's not as simple as just hitting approve on a computer. The Bitcoin network is designed to prevent fraud by requiring miners' computers to solve complex math problems before they can add a new block to the chain. Why math problems? These problems are hard to solve, but easy to verify. Imagine solving a fiendishly difficult puzzle and then showing everyone the completed puzzle to prove you did the work. That's essentially what miners do. Now, here's the reward for all that effort. The first miner to solve the problem wins the right to add the block to the blockchain, and in return, they get paid in new Bitcoin. This is how new Bitcoin is created and circulated into the system. But is mining profitable? It depends, because these miners aren't just solving puzzles for fun. They're competing against one another using powerful, energy-hungry computers to be the first to solve the problem. That competition eats up electricity, and a lot of it, making mining a costly endeavor. Now you might be thinking, what happens if someone tries to cheat the system? Say a bad actor, let's call him Bob, tries to rewrite the blockchain to send himself Bitcoin that he doesn't actually own. In theory, Bob would need to redo all the math puzzles for every single block from his attempted theft back to the very first block, also known as the Genesis block. And he'd have to do it faster than the rest of the global network combined. With the vast number of computers on the Bitcoin network, this is practically impossible. Bob's attempt would require unimaginable amounts of computational power and money. Because of these security measures, Bitcoin has earned the nickname trustless currency. You don't have to trust a bank, a government, or even another person to use it. The system itself ensures that transactions are legitimate and Bitcoin can't be double spent. But trustless doesn't mean lawless. Every transaction on the blockchain is public, although users are pseudonymous. Your transaction might look like random numbers to an outsider, but within the network, it has a clear link, providing transparency while maintaining privacy. One question people often ask is, why does Bitcoin have value if I can't hold it, see it, or use it everywhere? The answer lies in scarcity and belief. Like gold, Bitcoin is finite. There will only ever be 21 million Bitcoin in existence. No one can print more Bitcoin or flood the market with it. Plus, the more people and businesses adopt it, the more valuable it becomes. It's a feedback loop of trust, utility, and scarcity. But it's not all smooth sailing. Bitcoin comes with challenges. It's known for being volatile. Its price can skyrocket to dizzying heights or tumble drastically in a matter of days. Scalability is another issue. Bitcoin can only handle a limited number of transactions per second, which is minuscule compared to traditional payment processors like Visa. Developers are working on solutions like the Lightning Network to make Bitcoin faster and more practical for everyday use, but the road isn't without bumps. Then there's the environmental impact. Mining, with all its energy consumption, has sparked debates about sustainability. Some argue that renewable energy could help offset this, but the conversation is far from over. So, where does that leave us? Well, Bitcoin isn't just digital money, it's a technological breakthrough, a way to transfer value securely without middlemen, all happening in an open and decentralized system. It challenges our understanding of money and authority, pushing us to think about who or what we trust with our assets. Whether Bitcoin changes the world or remains a niche technology, one thing's clear. It's sparked a global conversation about innovation in finance, freedom, and the very nature of value. So the next time you hear about Bitcoin, you won't just think of it as an investment or a buzzword. Now, you'll really know how it actually works.